Okay, today's lesson is all about arc and sectors. And we're going to talk about what arcs are and how to find their length, and what sectors are and how to find their area. So I have animation videos, and then I'll show you example problems of each of those things. So let's get started right now. In order to understand arc measure, we have to go back to our definition of radian. Now remember, if you have an arc length on a circle of length r, then the angle that intercepts the two ends of that arc is, by definition, 1 radian. Therefore, if you have an arc length, and we showed this before, that's 2r, then the angle that intercepts the two ends of that arc is 2 radians. So, if we had some unknown angle that was theta radians in size, then the arc that intercepted that, and theta could be any measure of any angle. I drew it here to be that obtuse angle, but it could be anything. So if you have theta radians, then that means all you did before. Remember, 1 radian was 1r, 2 radians was 2r's. So theta radians is going to be theta r. And that gives us our arc length formula. The arc length formula is S equals theta r. Very simple to understand. The S is the length of the arc. That's usually what you're trying to find. Theta is the angle in radians. It won't work if you do it in degrees. And r is the radius of the circle. Example problem number 1. A circle has a radius of 16 centimeters. Find the length of an arc intercepted by a central angle of 22 degrees. Whoop. Okay, so up there, we've got the formula we're going to use, and over here, we have the r and theta that we decided. So, all we got to do is plug it in and do what we got to do. We're going to have to convert some things. So, S equals R times theta. So all we have to do is multiply 16 centimeters times 22 degrees. Except we can't do that. We can't have 22 degrees. We've got to put that into radians. So we do that first. So it's 22 times, remember radians is, to get to radians, we do pi over 180. Okay, so you got to multiply that by 22 times pi over 180, and now I've got to get a calculator again. Okay, calculator. So I just take the 22 times pi over 180. Now, because this is a real-world example, because I use centimeters and not just generic units, I know that this is a real-world problem where I'm going to be rounding. So I do 6 stat, I get how many radians? 0.383 radians. So I put in 0.383 radians. So now all I got to do is multiply the 16 centimeters times 0.383 radians. So I take that answer I got, times it by 16, and I get that 6.143. I'll say 6.14. And that's the end of that chapter. Example problem 2. A central angle in a circle with radius 8 meters is intercepted by an arc of length 20. Find the measure of the angle to the nearest degree. Same thing. Okay, so we got that up there, only we're going to do it backwards this time. Hope this doesn't work over here. Okay, so instead of knowing the angle and the radius, we know the radius and the S. So let's plug them in. So S, the arc length, is 20, and the radius was 8. So we have 20 equals 8 theta. So we got to get theta by itself, and then convert theta to degrees. So we divide both sides by 8. 20 divided by 8. We'll go ahead and use decimals because we have meters. 20 divided by 8. I'm not going to show you this one because you can do it. 2.5. Okay, so we have equals theta.
but that's in radians, and the problem specifically asks for degrees. So we just do the quick change up. Degrees, that's not a green pen. There's a green pen. Okay. So to change radians to degrees, instead of multiplying by pi over 180, you multiply by 180 over pi. So we take 2.5 times. Now remember, these are the ones that we had to round off because it wasn't because they gave me a decimal. I got to get a decimal. So 2.5 times 180 over pi. It looks like this. So the nearest degree is 143 degrees. That's that.
In order to understand sector area, you first have to understand what a sector is. A sector is kind of like a piece of pie cut out of a circle. That's formed by an angle and an arc. Angle always has to be from the center of the circle. So you have an angle and an arc that bound the sector, so it's very much exactly what you think of as a piece of pie. So that's defined by two things: the radius of the circle and the angle created by the central angle. So we're going to talk about how to find the area of the sector. Now, if the sector happened to be the entire circle, well, then the area would be very easy to find. The area of the whole circle is pi r squared. Knowing that, if you wanted to find the area of a sector that is half of the circle, well, that would be half of pi r squared. So it would be pi r squared times 1/2, because it's a fractional part. It's 1/2 of the whole circle. Similarly, if the sector was only 1/4 of the circle, then you take the pi r squared and multiply it times 1/4. So what you're always doing is you're always taking the pi r squared and you're multiplying it times the fraction that this sector makes up of the whole circle. So what if we don't know? What if it's theta? What if we don't know what the angle is? Well, we're still going to take that pi r squared. Okay, only we're going to think of the whole fractional part. And if we had the whole circle, well, the top part of the fraction is going to be theta. Theta, some unknown angle. And we're going to do it in radians. So theta is going to be in radians. So theta out of, what would the whole circle be? The whole circle would be 2 pi. So it's theta out of 2 pi radians. So that's our fraction. And you'll notice when we make that fraction, the pi's cancel out. So what we're really left with after we do this whole work is the sector area formula. So that's the formula you have to know for sector area. Okay? A is the sector area. Theta, that's the angle in radians. And r, that's the radius of a circle. The formula is A equals 1/2 theta r squared.
Last word problem. Find the area of a sector of a circle with radius 15 feet bounded by a 15-degree angle. Whole lot of 15s this time. So the radius is 15 feet, theta is 15 degrees. Can't plug 15 degrees in, have to change it to radians. So we do that first. 15 times pi over 180. All right. .262. So we'll go 0.262. So this equals 0.262 radians. Okay, so we got the 15 feet. We got that. Now it's just plugging it in. This means area equals 1/2 times theta, which is 0.262 times 15 squared. All right, well, 1/2 times 0.262 is, well, that's 1/2 is divided by 2. So that's wait, that's not going to work at all. Okay, I'll put it in the calculator. 0.5. I was right. 0.131. 15 squared. Oh, that's not right. 225. Ah, I should have known that one. So we got 1.131 times 225. 29.475. See? 29.475. And what's the units? Well, it's feet. And it's area, so it must mean it's square feet. So 29.475 feet squared. Easy peasy lemon squeezy.